The Sun is the largest object in the solar system. It is over 100 times wider than planet Earth. About 1.3 million planet Earths will fit perfectly into the Sun. It all began about 4.6 billion years ago, when the Sun began to form in the Milky Way galaxy, specifically in a region known as the Orion spur. A giant cloud of gas and dust called the solar nebula began to spin. As the nebula collapsed under its own gravity, it spun faster and flattened into a disk. Most of the nebula's material was pulled toward the center to form the Sun. Intense pressure mounted in the center of the Sun, and it became so hot and dense that hydrogen atoms fused together to form helium, releasing an immense amount of energy in the form of heat, radiation, light, solar wind, and electricity. This process is termed as thermonuclear fusion. After the fusion occurred, the young Sun was born. Much of the remaining material formed the planets and other objects that now orbit the Sun. Like all stars, the Sun will eventually run out of hydrogen in about 6 billion years from now and start to die. During this time, the Sun will expand into a red giant star, and it will engulf Mercury and Venus, and possibly Earth as well. After that, it will collapse into a little star called a white dwarf. This white dwarf will no longer produce energy by fusion, but it will still give off light and heat from its previous fusion for trillions of years to come. After that, scientists believe it will become a superdense black dwarf, giving off no more energy in the form of light and heat. However, scientists predict the Sun is a little less than halfway through its lifetime and will last at least another 5 billion years before it becomes a white dwarf. The Sun accounts for 99.8% of all the mass in the solar system. All the 8 planets and other bodies account for only 0.2% of the total mass of the solar system. Due to this mass, the Sun is equipped with intense gravity. Gravity is what keeps the Sun, along with the planets, moons, and other objects in orbit around it. This force arises from the mass of an object, pulling other objects closer to it. In the case of the Sun, its immense mass generates a gravitational pull that holds a system of celestial bodies in place, including the 8 planets, about 170 moons, numerous dwarf planets, and asteroids. Once the Sun loses its position, all of the objects in the solar system, including planet Earth, will drift apart into the empty space. The Sun has a diameter of about 864,600 miles, and it is made up of 6 layers or regions: the corona, the chromosphere, the photosphere, the convective zone, the radiative zone, and the core. Just as the Earth moves around the Sun, along with the entire solar system, also orbits the center of the Milky Way galaxy at an average speed of about 143 miles per second. It takes approximately 220 to 250 million Earth years for the Sun to complete one full orbit around the center of the Milky Way galaxy. This is known as a galactic year. One astronomical unit is equal to the average distance between the Earth and the Sun, which is approximately 93 million miles. This unit serves as a cosmic yardstick, enabling astronomers to conceptualize distances within the solar system and beyond. Due to this vast distance, light from the Sun takes approximately 8 minutes and 20 seconds to reach the Earth. This means the light we see on Earth actually began its journey over 8 minutes ago. Earth's orbit around the Sun is not perfectly circular, but elliptical, meaning its distance from the Sun fluctuates throughout the year. When the Earth is closest to the Sun, which is known as perihelion, the average distance between the two entities is about 91.4 million miles. This occurs around early January. Conversely, at aphelion, where the Earth reaches its farthest point from the Sun, the average distance stretches approximately 94.5 million miles. This typically occurs in early July. The Sun, also known as the yellow dwarf star, is composed mainly of about 75% hydrogen, 24% helium, and also traces of other heavier elements, which amounts to 1%. The core is the hottest part of the Sun. This is where hydrogen atoms fuse together to form helium. The temperature in the core is estimated to be around 15 million degrees Celsius. To put this into perspective, that is about 12,000 times hotter than volcanic magma, where temperatures can reach up to 1,200 degrees Celsius. Ancient civilizations across the globe revered the Sun. They attributed it with divine significance and crafted myths and rituals to honor its power. In Egypt, Ra, the sun god, was central to religious belief, symbolizing creation and vitality.